describes the importance and how-to of planning the duration of a capital. The purpose of this project is to utilize management tools to accurately plan for a capital project. In this specific example, the program Merlin is used to outline the plan's start, planned end. Shown here is the information input to Merlin. Listed on the left-hand side are the steps that comprise the entire capital project. The 5 main steps include strategic plan phase, project initiation phase, building design, construction phase, and occupancy. The project initiation phase and building design also have many sub-steps. To the immediate right of each step is the predecessor number, which indicates the order in which each task must be completed. Also shown are the planned duration, end, and start of each step, which is determined before the project begins. Once the project is started, the actual end and start dates are added, as is shown for the strategic plan phase, team formation, and master facility plan. In this slide, you can see the overall Gantt chart for the project. Although it is hard to see in detail, this zoomed-out view gives a good overview of the project, showing which steps have sub-steps and which tasks must take place before other specific tasks. Here you can see the close-up portion of the Gantt chart that is the strategic plan phase. Detailed for each step are the start date, end date, total work duration, and percent completion. Once all information is correctly entered into Merlin, the total length for each major step, as well as the entire project, is formulated. Specifically, the strategic plan phase will last for 5.23 months, the project initiation phase will take 8.77 months, the building design phase will last the longest with 8.97 months, the construction phase will be finished in 4.23 months, and the occupancy phase will be shortest with 1.33 months. Thus, the total length of the capital project will be 2.38 years. Overall, when a capital project is taken underway, it is vital that it is carefully planned in detail before beginning. Thus, the easiest and most comprehensive way to do so is through the use of management software such as Merlin. In this example, Merlin was simple to use, created clear outcomes, and produced helpful visual aids. Thus, planning for the overall duration of a project is necessary and can easily be done with the proper software, but it is also important to remember that planned durations will most likely change as a project ensues, and thus, the project planner should not remain static, but instead change and update the plan as necessary. The second half of this presentation looks at the rate of performance of a project, another important part of project management. The purpose of this rapid analysis is to look at the first few steps of a project once they have already been completed, compare their actual times to the originally estimated times, and then evaluate a more accurate time frame and plan for the remainder of the project. This analysis is done through calculating the rate of performance. Rate of performance equals actual duration over planned duration. Only activities in the critical path. I will now demonstrate the calculations discussed in the previous slide through this example. The chart shown displays activities A through H of a large project. The order of activities is shown, as well as the planned duration and planned expenditure for each step. The completed duration is only shown for steps A, B, and C because those are the only steps that have taken place this far. Therefore, these steps will be used to calculate the rate of performance. However, step C is ignored as it is not in the critical pathway of the project. First, the planned duration and completed duration for activity A and B are combined so that the planned duration equals 3 weeks and the actual duration is 6 weeks. Then, the rate of performance is computed by putting the actual duration over the planned duration. Thus, the rate of performance is 200%. With the computed rate of performance, we can now estimate the project end more accurately. To do so, we multiply the project duration by the rate of performance. When computing the project duration, the total number of weeks for each step are combined. Still, the steps not in the critical pathway are excluded. For this example, steps C and G are therefore ignored, and the total planned duration equals 12 weeks. Thus, when multiplied by 200%, the estimated project end is in 24 weeks total. This is twice as long as the original estimate. Therefore, we know that the project will be over budget. As a project manager, it is important to remember that project planning is not over once the project begins. Planning and evaluation must continue throughout the entire process. Therefore, rate of performance analysis is an accurate way of determining if a project will end on target or not. It also allows the manager to adjust the budget of a project. Still, it is important to remember that the project will constantly be changing, and although this example shows that the first two steps took longer than expected, future steps may be completed quicker. Therefore, the project manager must remain flexible.